In the last episode of this series, we deployed a Kubernetes cluster on DigitalOcean as well as our database. We did that manually through the UI, but I have an article on my blog which covers how you can do that using Terraform to build your infrastructure on DigitalOcean. And yeah, I go into more details here if you are curious. So you would have all the provisioning code also checked out in the repository. I'm gonna leave all the links in the comments below. So it's time to deploy our application. But before we do that, let's discuss a bit about concurrency and process models. The 12-factor manifest is a methodology for writing web applications that can be easily operated in the cloud. It was initially drafted by the Heroku team, but the ideas described there apply to any hosting platform, including containers and Kubernetes. In fact, the Heroku platform uses the container model as well. So the dynos on Heroku are containers. When you push your code to Heroku to deploy, what Heroku is doing is essentially packaging your application in a container. One of the points of the manifest is about concurrency. The main idea is that the application should adopt a process model that enables scaling your application horizontally, which means more processes and possibly running on different machines instead of vertically, which means more resources like CPU and RAM. Each process type is an entry point to your application, as pointed out in this article, also linked in the manifest. It goes over on how you can apply the Unix process model to web applications. Highly recommend checking this out. A Laravel application, for instance, has at least 3 entry points. As you can see, it matches this diagram here. So we have a web process type, which receives HTTP requests. And we also have a worker process type, which handles background jobs. And we also have a clock process type, which is Laravel's scheduler. We are going to start writing our Kubernetes objects or manifests. And we could simply create a folder here in our application and name it Kubernetes or deploy or whatever you name it. But I don't like that approach. See, the application has a different workflow than our configuration and deploy management. So I like to keep those separate. I first saw this idea in this talk called Kubernetes the Easy Way, and I've been using that in some projects and liking it. The idea is to keep the Kubernetes files on its own repository on Git, so we can have different workflows running in that infrastructure repository. So I went ahead and created a folder which will hold all our infrastructure code, and this is the application that we are using. My terminal is already connected to my Kubernetes cluster on DigitalOcean, as you can see. In the previous video, we saw that there are many different kinds of objects in Kubernetes, and they all have different use cases. We are going to touch again on services deployment, but we are also going to see jobs, cron jobs, and stateful sets. So let's get started. I opened up the infrastructure folder on PHP Storm, and it's empty, as you can see. But in the previous video, we were manually creating the files, and we didn't have much structure, besides the fact that they all live in the same folder. We are going to add some structure here, and we are also going to see a different way to write and manage the Kubernetes manifests, which is using Customize. Customize solves a few problems we would have to handle manually if we didn't use it. And we are going to see some of these problems in the next videos when we talk about secrets. But the best part is Customize comes built in with kubectl, so we can already use it. First, let's create our customization file. So in the root folder, I'm going to create a new file called Customization. And in this file, I'm only going to specify a namespace. Most things that I can specify here in the top level customization file, they will be applied to all our Kubernetes objects. This namespace will be injected in our Kubernetes objects, so we don't have to keep specifying it. Oh yeah, about namespaces. Kubernetes has a way to virtually separate clusters in the same physical Kubernetes cluster, which is called namespaces. So we are going to make use of that here. So we just have to specify the namespace name. So let's do that. First thing, we are going to create a new folder here called Applications. And inside of it, we are going to create the namespace YAML. And here we're going to paste that code that we saw. And the namespace name will be Docker for Laravel. And we have to point that out in our customization file. So now let's see what this does. I'm gonna open the terminal and run kubectl customize. As you can see, it doesn't change much, but we'll see more changes as we add more resources. So for now, let's apply this change to our cluster. And how can we do that? Well, customize process all our resources and outputs them in a single YAML file. So we could pipe this to kubectl and apply using the -f flag for file, but instead of specifying the file, we specify that it's coming from standard in. This is going to get the output of this command and send to as the standard input of this command. And we got our namespace created. So if we go ahead to our control panel on DigitalOcean and we get to our cluster, we'll see that there is a Kubernetes dashboard link. And if we click on that, then we get access to our Kubernetes dashboard. This is pretty cool and it's going to be really useful down the road. So if we go here to the namespaces dropdown, you can see that there is a Docker for Laravel namespace, and right now it's mostly empty. As we add more resources, we are going to see them showing up here in the dashboard. So let's start with the most difficult part, which is Redis. As I said in the previous video, we could run Redis as a dedicated service on DigitalOcean, and in a real project I would recommend that, especially if you're using it also for queues. For now, let's have Redis as a stateful set. So Redis persists our data in the /data folder, as we saw in the early videos, and we need to put that folder in a volume. Kubernetes doesn't come with any persistent storage out of the box, which means that if our Redis pod dies, all the data that was stored in the /data folder would be gone. We don't want that. As I said, it doesn't persist our data automatically for us, but we definitely can do that with Kubernetes. First, we need to claim the storage space to our cloud provider. For that, we can use an object called persistent volume claim. So let's create that. In our applications folder, I'm going to create another folder called Redis1. I'm numbering the Redis folder because potentially I could have multiple Redis applications running in the same cluster, as Redis has a limitation of database counts, which is 16, I think. So I could run multiple instances instead of running a Redis cluster. So let's create our PVC, our persistent volume claim. I'm going to create a file named PVC for persistent volume claim, and in that, I'm gonna paste here the content and we'll discuss it. So as you can see, it's a kind of persistent volume claim, and this is the name, and this is the access mode. This is really important because we are saying that if Kubernetes mounts this volume to a pod, no other pod can mount the same volume. We only want one pod to read and write in this volume. And here we request some resources, which we are requesting 20 gigs of storage. So let's see what Customize builds with that. And oh yeah, we have to point that out in our customization file as well. Now let's build it. So as you can see, it appended the namespace. We don't have that in our YAML file, but it did inject that at build time. So let's create that. We could keep piping it to the apply, but kubectl has a flag, -key flag, that we can use, which does essentially the same. It runs customize build and applies the changes to our cluster. So if you go back to the control panel under volumes, we can see that DigitalOcean created us a new volume for us based on our claim, which was 20 gigs. Volumes aren't free, so yeah, we are paying per volume, but it's pretty cheap though. It's like for the 20 gigs, we are actually paying $0.003 an hour, but do keep that in mind. Differently than deployments, stateful sets, they have a two-way connection with the service of the pods. So in order to create this stateful set, we actually need to create the service first. So let's create a service. I'm gonna call svc.yaml, and I'm gonna copy this and paste here. So there's nothing new here. We already saw services in the previous video. So we are creating an object of kind service and we are giving it a name of Redis01 SVC. And here we're specifying the ports rule, which is mainly the Redis default port. And we don't have to specify the target port if they are the same. So in this case, they are the same, so we don't have to specify it. And here's the selector, which is going to match with the stateful sets pod. So let's go ahead and create the stateful set. I'm going to copy it here and paste the content. And we are going to go over it. So here we're specifying this object of type stateful set, and this is the name of the object. And here we specify the service name. As you saw in the previous file, we named it as Redis01 SVC. So that's what we specified there in the stateful set. And here we are defining the stateful sets matching labels criteria. And in template, we specify the pods, the template of the pods that are going to run in this stateful set. So in this case, we create some metadata, which is the label that we are matching both in the stateful set and in the service, and the container, which we are running Redis. We could specify here that we want Redis 5, and we probably should do that. And here we specify the port of this container, and we are also mounting a volume here. And the volume is named Redis persistent storage, and it mounts under the /data folder. And here we specify the volume. So we are creating that volume that we are mounting there in the container, and we are specifying the persistent volume claim, which is the one that we just created. So you might be thinking, why can't we just use the deployment here instead of our stateful set? Or why do we need a stateful set? Well, deployments are great for stateless applications. You can provide replication rules that can guarantee at least one or at least two instances running at the same time. But stateful applications usually don't play nice with having multiple instances running at the same time. Well, not out of the box at least. For many stateful applications, identity is important, and in some cases, they were built with a single server in mind, and only then had to support horizontal scaling. So our at least one or at least two guarantee provided by the deployment isn't enough here. We need something like at most one or at most two instances. The stateful set does all it can to guarantee that. For more information on this, I highly recommend chapter 11 on this ebook on Kubernetes patterns. It's free thanks to Red Hat. So chapter 11 goes all about stateful services and how we can run that on Kubernetes and why is it important and what kind of guarantees we have with it. So I highly recommend it. Let's apply the changes to our cluster. First, we need to point out both the service and the stateful set in our customization file. Let's build it first so we can see what it creates for us. So yeah, we can see that it added the namespace to both, so that's good. Let's apply this to our cluster. You can see it created the service and the stateful set. So if we go back to the dashboard, we can see that there is a new stateful set deployment going on, and we should see green soon here. All good. So let's try to reach it. I'm gonna run kubectl get pods, but I do have to specify the namespace. And there is a pod running for Redis, so I'm gonna copy that, and I'm gonna run kubectl, and I'm gonna execute a command inside of this pod. And the command I'm going to use is Redis CLI, which is going to start a session in a Redis REPL for us. And in here, I'm going to ping the pod, and it replied with a pong, which means everything's running. So let's test out if I can delete this pod and recreate it. And to do that, I'm gonna exit here, and I'm gonna run kubectl get pods -n, specify the namespace, and I'm going to specify a -w here, which is a watch, and I'm going to create a new terminal session, and in here I'm going to run kubectl delete pods and specify that pod name and the namespace as well. So if we go back to that other screen, we can see that it will terminate that pod and create a new one. So it's terminating the pod and recreating it automatically for us. And it's already running again. So we can actually run that same command and it will just work. Because differently than deployments, the stateful sets do persist the same pattern of identity. So let's try something. Let's create a key here. So we can see that we stored that, and let's delete it. And it's already running again. So we can go back to the Redis CLI. And if we try to get Lauren again, we see that it actually persisted across restart. So that's good. Okay, so we already got Redis running. Now let's create a deployment for our web application. So under applications, I'm gonna create a new folder called Laravel app. And in here, we are going to create a deployment file. So we could create the file manually, but I want to show you something else. We can actually use kubectl to create a deployment template for us. So if we run kubectl create deploy and we specify a name, which I'm gonna call just web, and we specify an image. And here we can use our image, but I'm just going to place nginx as a template for us. And I don't want this to create the deployment in the cluster, so I'm gonna run dry run, and I'm gonna set the output as a YAML. So as you can see, it created the deployment template for us. All we can do is direct that to a file. So I'm going to put that under applications Laravel, and I'm gonna call it web.yaml. So if you close it, and yeah, here it is. So we now just have to tweak it. I'm gonna delete the creation timestamp here, and also the creation timestamp here, and also the status here. We don't need that. We do need resources, but I'll leave that for a later video. For now, let's just delete it here. So this part looks okay to me. I want 3 replicas of this application running. This looks okay. So under strategy is how you can configure the deployment strategy of this deployment. I'm gonna set the type as rolling update, but this is the default type. We can control here, like let's say we want to limit the unavailable pods number to 1. So this means that when rolling out the new release of the application, it will terminate the pods one by one, and we'll create the new pods with the new versions also one by one, which is controlled by the max search. That's why I actually wanted 3 here, so we could see the application rolling out one by one. And here's the template of the application. So this part we are going to change it. Instead of just running the nginx image, we actually want our custom image, which is this one. And we instead of latest, we want 001. We also have to specify the port here. And this pod actually uses 2 containers, so we can specify another container here. And this container will be the PHP one. And we are going to name it PHP. And we don't have to specify the port because this container is not exposed. Only the nginx will be exposed, so we can remove that. But we do have to configure our Laravel application, and the way we do that is with environment variables. I'm gonna create here a new env configuration, and we can actually specify the environment variables here in the deployment object itself. And the syntax is this one. So we specify the name of the environment variable, which is the key, and the value, which is in this case is Docker for Laravel. And we do that for all the other keys as well. So each key will have an entry here. I'm gonna copy all the keys so we don't have to see me typing them all here. Okay, and now we actually have to go over it. So there's a duplicate here. So this is the environment of the application, and I'm gonna leave it as development. The app key, we have to generate that one. So I'm gonna go back to the application folder, and I'm gonna run a command here to generate the key. So now we can actually copy this and go back to our YAML file and paste it here. This is a bit ugly to specify it here, especially because we are going to be copying these to other resources soon. And in the next video, we are actually going to see how we can better manage this. So this is the domain that we are going to use. Let's configure the database. Oh, yeah, the log channel. I'm setting it to standard error because we shouldn't use log files in containers, as we don't have much control over the disk. So all the logs should be redirected to either standard out or standard error. And now we have to configure the database. So I'm gonna go to the control panel on DigitalOcean on the databases, go to my database, and in here I'm gonna copy the host. The port is the same one. Yeah, it's correct. So the database name is this one, and we have to create it. We didn't create it yet. So we are going to users and database and create a new database here. And we also need to create this user. So let's go ahead and create it. And this is the password. So let's copy it and paste it in our configuration file. We are configuring the cache and session to both use the Redis connection, and also the queue driver is also using Redis. And here we are setting the Redis host, and the rest looks good to me. So let's go ahead and add that to our customization file and apply it to our cluster. So if you go back to the dashboard, Kubernetes dashboard, you can see that there is a new web version running and something's wrong here. So let's see what's going on. Oh, there was an error pulling the image. Let's see. Which image was it? So let's go to my profile. It's a different name. My bad. So let's go back there, change it. And the same for the PHP one. Now let's apply it. So if we go back to overview, changes being propagated, the containers are being created. Nice, so it seems to be working. However, we can't open this application in the browser just yet, and that's because we haven't configured a way to handle outside traffic from our application. And in the previous video, we saw one way to do that, which is using a service of type load balancer. That works great, but if you have other web applications running in the same cluster, receiving HTTP requests, that would add up extra costs, as you would have one dedicated load balancer per web application. And to solve this, we can use something called Ingress. So Ingress is an object for managing external access to our services inside the cluster. It's something that sits between the internet and our applications in the cluster, as you can see here. And there are many ways we can configure this routing traffic. And here we are actually sending any request for this path in this ingress will be sent to this service on port 80. There are other ways instead of path-based, which is by using hosts. I think there is one here. Yeah, so we can do hosts. So we can have many sites running in the same Kubernetes cluster using a single ingress, which is a load balancer on DigitalOcean, and routing that through the ingress itself. To be able to use ingress, we need to install an ingress controller in our cluster. And for that, we are going to use Helm. Helm is the package manager for Kubernetes. Think Composer or NPM, but for your Kubernetes cluster. You need to install it in your machine. It's a binary as well. So you download it, give it execute permission, and you're ready to go. Helm packages are called charts. Ingress has its own chart here. So if you look for nginx ingress, you see there are many implementations. The one that we are going to be using is this one. I already have Helm installed here, so we can simply copy this command and run it. But we do need to set a configuration here, and the configuration that I'm looking for is called publish service. If we enable this one, it will publish the load balancer for us. So let's set that. Oh, we have to specify the name. I'm gonna call it nginx ingress. So this is the syntax, the name of the thing that we are installing, and the package or the chart that we are using, and your configurations. And looks like it already did it. So it's telling us how we can actually use this ingress. If we go back to our control panel on DigitalOcean, under networking, load balancers, we can see that there is a new load balancer being provisioned. I'm going to be creating our Ingress configuration here. So I'm going to create a new file called main ingress.yaml, and I'm going to paste the content here. So we are actually defining that any request coming to this host name, will be redirected to the web service. But we haven't created this service yet. Let's do that. Under applications, Laravel app, we are going to create a new file called svc.yaml. And in there, we are going to create our service. Differently than before, we are setting the type to cluster IP. While before we were using type load balancer. This time we don't want that. The difference between a service of type cluster IP and load balancer is that the cluster IP exposes the service internally in the cluster, while the load balancer talks to the cloud provider and in order to provision a load balancer for us, an external one. So everything looks fine here. Now let's see if the load balancer is provisioned. Yeah, looks like it is. I'm gonna go ahead to my Cloudflare account. So I'm gonna point my domain to this. I did that behind the scenes, and now we can actually apply the changes to our cluster. So now if you go back to the terminal, oh yeah, we have to add these new resources to our customization file. So let's do that. I'm gonna add the main ingress here. Oh, I guess below the namespace. And I'm also going to add this service here for our web application. And I think we are ready now. Let's apply the changes. And looks like the changes were made. Everything seems to be created here. We get the new services here. So let's see if we can reach the application. And nice, it's already running. Our application is now reachable in the browser, but if we try to sign up here, we should see an error saying that there is no database. Yeah, there's no table named users. That's because we haven't run the migrations yet. We are going to see how we can actually automatically run migrations while we are deploying in a later video. But for now, let's run it manually. I'm going to use kubectl get pods here. And I'm gonna select one of the pods. And now I'm gonna run a command inside of that pod. Oh yeah, I have to specify the container, because this pod actually runs two containers, the nginx and the PHP one. And to be able to run a command inside of it, I have to specify which container I want to use. So I'm going to specify -c flag for containers and the name of the container, which is PHP. And the command that we are going to run is php artisan migrate. And we successfully ran our migrations. So if we go back to the application now and try that request again, we successfully created our user. And yeah, that's good. But we still don't have any workers and the scheduler isn't running as well. So let's solve that. I went ahead to the application itself and I made some changes to it. So instead of using the default worker for Laravel, I installed Horizon, and I also created some new classes here. So I add the Horizon dependencies, which is this PC and TL extension, and I also added a schedule job. So this clock job is going to run every minute. I created a new action in the home controller that dispatches a job so we can see the job working. And the clock job, all it does is log the tick tick message. And the example job, it logs the hello from the job message. And this is the Horizon configuration stuff. And yeah, all seems okay here. I added a new environment here, which is development, to match our development environment that we are using in the appenv key. And yeah, the new button in the home So once we deploy the new version here, we will see a button here that we can click and that will fire a job. I already also created a new tag for this with these changes, so we can actually already deploy it. So let's do that. Let's make some changes and deploy the new version. So we actually are going to copy the web deployment and we are going to paste it inside the Laravel app and we are going to call it worker. I'm gonna change everything that mentions web to be worker. And everything else looks okay, except that the worker version doesn't need Nginx, so I'm not going to leave it here. I'm going to remove it. And I think we are ready now. Let's put the worker file to our customization file and apply the changes to our cluster. We forgot to update the image version. And as you can see, I only have 2 deployments here using this image, but yeah, it's already duplicated in 2 places and I don't like that. So turns out that Kustomize has a way to solve this. So instead of specifying the image here, we can actually use named images. So I'm going to create a new configuration here and I'm going to specify the image name, which in this case will be Laravel app Nginx. And the new name is the image name, and I'm gonna copy that one. And the version we specify in new tag. So whenever we mention this and the tag name, we can actually mention just the name of the named image. So we can go back here and change this to just this, and Kustomize will replace this with the image name and tag. And we can do the same for the PHP image as well. So now we can use this name here and we can do the same for the worker. So instead of specifying the image, we just specify the name of the image and Kustomize will do the replacing. So if we test that out, kubectl, and we look for the deployments, this is the deployment, we can see that it actually replaced the image name, so that's good. But we actually want to update the image version, so let's do that here. We're going to specify version 2 and also version 2 for the PHP one. And now we can actually run kubectl apply, and that should roll out a new deployment for us. I think we are good now. Yeah. So if we refresh this page, we should see the new button. This is the new version, which means that if we go back to /horizon here, we should see the dashboard, which is forbidden. Yeah. So I actually have to allow, it's in the providers horizon. So I actually have to allow the emails, and I'm gonna do that, build a new version and go back here. I'm gonna allow any user. So now we can actually build a new image. Okay, now we can go back to the infrastructure repository and change this to version 003. And now we can apply that to the cluster. And let's wait the deployment to finish. And it seems like everything's back. So if we refresh here, everything should be fine. And if we refresh the horizon, and we should now see the dashboard. As you can see, there are no workers active, even though we do have workers deployed. You have to remember that the default PHP image runs fpm, and it should actually run the horizon command. But how can we do that? So the way we do that is by overriding the entry point of the Docker file, and we override the entry point in Kubernetes using the command. Yeah, I know. Docker also has a command entry that you can use, and there are some difference between entry points and command. This video from Server for Hackers goes in depth on explaining the difference between an entry point and a command. But in Kubernetes, the command field actually corresponds to the entry point. Yeah, I know. It is what it is. So here's the table summary. The Docker entry point is the Kubernetes command field, and the Docker command field is the Kubernetes args. So if we wanted to overwrite the commands, we specify the args field, and in this case we want to overwrite the entry point, so we overwrite the command field. So let's go ahead and change this to run php artisan horizon, and yeah, you specify it as in this format. So now we can redeploy to our cluster, and if we go back to the horizon dashboard, you should see the workers popping up. So looks like everything's good now. We have 3 workers, each with 5 processes, so 15 processes in total. That's good. So now let's execute some jobs. Also, yeah, recently Laravel changed the configuration key to queue connection. So let's change it in our file here. So instead of queue driver, we have to set the queue connection. So that's why the jobs were not being dispatched to Horizon. So let's do that here and apply the change to our cluster. It seems like everything is running. So let's go back to the dashboard on Horizon and let's dispatch some jobs to the queue and see if it, yeah, you see, 1 job processed. So let's dispatch multiple jobs, and you can see that the jobs are, yeah, being handled, and we can see here the job itself and all that. So that's good. There are no pending jobs. Yeah, everything seems to be working fine. So we have queues and jobs. We are missing the scheduler. So let's go ahead and create the scheduler for us. So I'm gonna create a scheduler file here, and in there we are going to paste the scheduler configuration. And as these environment variables might be outdated already, I'm actually going to copy the ones from one of these services. Oh yeah, we have to specify the env here and then this. So okay, so this one is simple enough. So we actually are creating an object of type cron job, and this is the schedule pattern, the cron pattern, and this is the template for the job itself. So Kubernetes will imitate the operating system cron job and will invoke this container every minute for us, and everything else seems to be okay. Let's go back here and use the named image instead of specifying the image here. And now I think we are done. We actually have to point that out, the new resource in our customization file. So let's do that. And now we are going to apply the change and create the scheduler or the cron job in our cluster. And if everything is all right, we should be able to see, yeah, there's a scheduler here, and this is the pattern, and there are no active jobs. If we wait a bit, we should see something popping up here. So okay, we see a new invocation here, and it took 8 seconds. 1 minute for now, and there should be a new invocation here. And if that worked, you remember that we actually are running a job. So if we check the completed job, we can see that there is a new clock job here. It means that the scheduler is running. So let's wait for it to run 1 more time, and then we will call it. You'll see a second invocation, and in here there should be a second clock job, so that's good. So yeah, one of the commits that I mentioned is that I created an API endpoint that returns the configuration app name for us. So if we hit this endpoint, let's create, yeah, let's curl it. And as you can see here, we see the configuration that we sent. So if we do while true and this, and then we sleep for 1 second and finish this. Yeah, so let's do something here. Okay, so let's try the deployment rolling. So if we actually run that command inside a while loop with a sleep of 1 second, we can see that we are pinging that endpoint and outputting the format. So let's do something fancy here. Let's change the configuration of the web, just this one for now, and we are going to release hey, and let's apply that to the cluster and go back to the terminal and watch the release going on. So as you can see, it starts, yeah, there was no downtime. Let's increase this to 10 and deploy the changes. So we will have 10 web pods running, and it seems to be working. And we have 10 instances of the web pod running. Let's do a while loop and curl that API endpoint and sleep for 1 second and poll again. So now let's change it here, the configuration to be hey, and let's apply that change to our cluster. So if you go back here, we should see the deployment rolling out, and we should see the new responses coming in, and you can see that we already got a response for one of the new pods, and then the old pods are still running. So eventually we'll only get the new pods answers. So yeah, that was it. That was a full walkthrough on how we can actually deploy a Laravel application. It's a lot because I'm going in steps, but this process can be simplified a lot and goes much faster than this. You might have noticed that there are some duplications in place. Like the environment variables are duplicated in the web, worker, and scheduler. So we are going to take a look at that in the upcoming secrets episode. That's all I had to show in this episode. In the next video, we are going to solve the configuration duplication using secrets and see how Kustomize can help us with that. So let me know what you think and stay tuned.